The night sky is a tapestry of sparkling lights. Each point of light tells a story. These stories span millions, sometimes billions of years. The cosmos is vast and filled with wonders. Imagine standing on a hill, looking up at the stars. The beauty is overwhelming. It's hard to grasp how far away these stars are. Some are so distant that their light takes thousands of years to reach us. The universe is a vast expanse full of mysteries. It holds secrets waiting to be uncovered. Our journey begins by exploring one of the most fascinating phenomena: stars. Stars are the building blocks of galaxies. They are born, live, and die, each leaving a mark on the cosmos. Let's dive into the life cycle of these cosmic giants. Stars are born in clouds of gas and dust. These clouds are called nebulae. Nebulae are the stellar nurseries of the universe. They are found in galaxies far and wide. In a nebula, gravity pulls gas and dust together. This forms a dense core. As the core collapses, it heats up. This hot core is the beginning of a star. We call it a protostar. Protostars continue to gather mass from the surrounding nebula. They grow hotter and denser. Eventually, the temperature and pressure become high enough for nuclear fusion to start. This marks the birth of a new star. The process of star formation can take millions of years. It's a slow and steady journey. But once nuclear fusion begins, a star is born, shining brightly in the cosmos. Once a star is born, it enters the main sequence phase. This is the longest stage in a star's life. During this phase, nuclear fusion occurs in the star's core. Hydrogen atoms fuse to form helium, releasing energy. This energy makes the star shine. The balance between gravity and fusion keeps the star stable. Our sun is a main sequence star. It's been shining for about 4.6 billion years and will continue for another 5 billion years. Main sequence stars come in different sizes and colors. The most massive stars are blue and very hot. Smaller stars are red and cooler. The mass of a star determines its lifespan. Massive stars burn their fuel quickly and have shorter lives. Stars spend most of their lives in the main sequence phase, but as they exhaust their hydrogen fuel, they begin to change. These changes lead to the next dramatic phases in a star's life. Not all stars are the same. They vary in mass and composition. These differences affect their life cycles. Massive stars have more fuel but burn it quickly. Smaller stars burn fuel slowly and live longer. Massive stars are often blue and very hot. They can be over 20 times the mass of our sun. These stars have short, intense lives. They end in spectacular explosions called supernovas. Smaller stars, like red dwarfs, are cooler and live much longer. A red dwarf can shine for trillions of years. Our sun is a medium-sized star, known as a yellow dwarf. It has a balanced lifespan. The composition of a star also matters. Stars are mostly made of hydrogen and helium, but they contain other elements too. These elements affect the star's color, temperature, and lifespan. Understanding these differences helps astronomers predict a star's future. It also reveals more about the history and evolution of the universe. As stars exhaust their hydrogen fuel, they leave the main sequence. They enter the next phase of their life cycle. For medium-sized stars like our sun, this means becoming a red giant. In the red giant phase, the star expands. Its outer layers cool and turn red. The core contracts and heats up. Helium fusion begins, creating heavier elements like carbon and oxygen. Massive stars become supergiants. These stars go through multiple stages of fusion. They create elements up to iron in their cores. Supergiants are incredibly bright and large. The red giant or supergiant phase is a time of change. The star's outer layers are often lost in stellar winds. These layers enrich the surrounding space with new elements. This process is crucial for the formation of new stars and planets. The aging process of a star is a prelude to its dramatic end. The next stage in a star's life is often its most spectacular. The end of a massive star's life is marked by a supernova. This is one of the most powerful explosions in the universe. When the core of a massive star collapses, it triggers a supernova. In a supernova, the outer layers of the star are blasted into space. The explosion is so bright it can outshine an entire galaxy. Supernovas release enormous amounts of energy and create heavy elements like gold and uranium. Supernovas are not just dramatic, they are essential for life. The elements created in these explosions are scattered across the cosmos. They become part of new stars, planets, and even life forms. Our sun will not end in a supernova. Instead, it will shed its outer layers and form a planetary nebula. The core will become a white dwarf, slowly cooling over billions of years. Supernovas are rare but awe-inspiring events. They remind us of the incredible power and beauty of the universe. For the most massive stars, the end is even more extreme. After a supernova, the core may collapse into a black hole. Black holes are regions of space where gravity is so strong, not even light can escape. The formation of a black hole begins with the collapse of a massive star's core. As the core contracts, it becomes incredibly dense. Eventually, it forms a singularity, a point of infinite density. Black holes are mysterious and fascinating. They warp space and time around them. Anything that gets too close is pulled in, unable to escape. This boundary is called the event horizon. Despite their name, black holes are not empty. They can have masses millions or even billions of times that of our sun. They play a crucial role in the evolution of galaxies. Black holes are the ultimate fate of the most massive stars. They remain one of the most intriguing phenomena in the universe, challenging our understanding of physics. Not all massive stars become black holes. Some end their lives as neutron stars. Neutron stars are incredibly dense remnants of supernova explosions. They are composed almost entirely of neutrons. A neutron star is only about 20 kilometers in diameter but has a mass greater than our sun. The density is so high that a sugar cube-sized amount of neutron star material would weigh billions of tons on Earth. Some neutron stars become pulsars. Pulsars are neutron stars that emit beams of radiation. As they rotate, these beams sweep across space like lighthouse beams. When the beam points toward Earth, we detect a pulse of radiation. Pulsars are precise cosmic clocks. Their regular pulses help astronomers study extreme states of matter and test theories of gravity. They are fascinating objects that reveal the incredible diversity of stellar remnants. Neutron stars and pulsars are the remnants of stars that once shone brightly. They continue to intrigue scientists and provide valuable insights into the nature of the universe. Stars are not just beautiful points of light. They have a profound impact on the universe. They create and distribute elements essential for life. The death of stars leads to the formation of new stars and planets. Stars also influence the structure of galaxies. Their gravitational pull affects the movement of gas and dust. Supernova explosions trigger the formation of new stars. Black holes at the centers of galaxies shape their evolution. The light from stars allows us to study the universe. By analyzing starlight, astronomers learn about the composition, temperature, and movement of celestial objects. Stars are our cosmic beacons, guiding our exploration of the cosmos. The impact of stars extends beyond their lifetimes. The elements they create become part of new stars, planets, and life forms. Our very existence is tied to the life cycles of stars. Stars are the engines of the universe. They drive the processes that shape galaxies and create the building blocks of life. Their impact is profound and far-reaching. The study of stars is an ongoing journey. Astronomers use advanced telescopes and spacecraft to explore the cosmos. They seek to understand the life cycles of stars and the mysteries of black holes and neutron stars. New discoveries are made every day. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope provide stunning images and valuable data. Space missions like the Parker Solar Probe study our sun up close. The exploration of stars also involves theoretical research. Scientists use computer simulations to model stellar processes. They test theories of gravity and nuclear fusion. This research helps us understand the fundamental laws of nature. The journey of discovery is far from over. As technology advances, we will uncover more secrets of the cosmos. The study of stars will continue to inspire and amaze us. Astronomy is a field of endless possibilities. Each discovery brings us closer to understanding the universe and our place in it. The exploration of stars is a testament to human curiosity and the quest for knowledge.